Good morning, grade 11s. This is going to be the last of our lessons for our solutions unit. What I want to talk about today is making dilutions. Quite often in our lab, we're going to be given a liquid solution, but it's going to be too concentrated, and we're going to need to dilute it to make it safe to use. So, for example, when I buy hydrochloric acid from my lab suppliers, it comes in a 12 molar concentration. That means there's 12 moles of hydrogen chloride in every 1 liter of solution. And that's just way too concentrated for us to use for the most part. So I need to quite often add water to it so I can dilute the solution and make it into a concentration that is safer for us to use or more appropriate to the lab. But I don't just add water willy-nilly. I have to know exactly how much to add to get the concentration that I want. So what I want to do is today explain how do I figure out how much water do I add, how much of the strong stuff do I need, and how do I make this? I have a little note here that I want you to pay attention to, and this is specific to mixing acids, and if we were in the lab, we probably could do this. But when we're diluting acids, it's really important that we're pouring our concentrated acid into our water, not the other way around. If you dump water onto a highly concentrated acid, it tends to spit and to splash, and you can get acid splashing back on your skin. So when you're making acid dilutions, we always start by putting water in first and then adding the amount of concentrated acid to it. And that's not something we worry about for other solutions we're diluting, but it does matter for acid solutions. So using that acid solution that we were talking about, that 12 molar hydrochloric, how could I make 25 mils of half a molar hydrochloric? Well, this is a dilutions question. I have the 12 molar that I talked about on the previous page, but I only want half molar. I want to make it more diluted. You'll notice that this molarity is a lot less than the 12 that I'm starting with. I also know that I only want 25 mils of it at the end of the day. I don't want to waste a bunch of chemical and make too much. Now, when it comes to doing a dilutions question, we have a formula that we're going to use. The formula is MCVC equals MdVd, where M stands for molarity and V stands for volume. C is the concentrated or stronger of the two solutions, and D is the diluted or weaker of the two solutions. We have 3 numbers that we're dealing with here. We know we have 25 mils of half a molar HCl. I want you to pay attention to the word of, because it is a linking word. It tells us that these 2 numbers, the 25 mils and the 0.5 molar, belong together. In this case, this will be the diluted, the MD and the VD. I know they're diluted because, one, I'm making them. I can't make something more concentrated by adding water. But also, I know that I'm using the school stock solution, which we said on the previous page was a 12 molar solution. So this 12 molar solution is clearly much more concentrated than a half molar solution. So when I substitute, the molarity of the concentrated will be the 12 molar. It's the more concentrated of the two. The molarity of the diluted will be the half molar. It's a smaller number, so it's more diluted. 25 mils is how much of the diluted one I'm making. So again, a little clue is to look for the word of to know which 2 numbers go together. Now, rearranging to solve for the volume of the concentrate, I'll go 0.5 times 25 divided by 12. I'm going to get 1.04 mils. I know my answer for my volume here will be milliliters because it was milliliters on this side. So what I would do is I'd measure my 1.04 mils of concentrated HCl, and I would dilute it up to 25 mils with distilled water. Remember, my solutions are always my total combined volume. So in this whole unit, there's really only 3 kinds of questions I can give you. I can give you dilutions questions like I just showed you, and we'll do a couple more examples. Or I can give you our regular 2 styles of molarity questions. So how do you know if it's going to be a dilutions question? Well, there's 2 clues for dilutions questions. You're either going to see the word dilute in the question, which is a good clue that you're diluting something, Or the question is going to give you two different molarities in the same question, one for the concentrated, one for the diluted. If you're given either of these two clues, you immediately write down your dilutions formula, then substitute and solve. If it's not a dilutions question, if they haven't given us these two clues, then we're doing a factor label line question like we've been practicing for the past few days. If they give you molarity, also called concentration, then start with it. Remember to change molarity to moles per liter. The other given will end up going beside it. If they didn't give you molarity, then they must have asked you for molarity. If they ask you to solve for molarity, then you put your given measurement, your grams or your moles, over your given volume in mils or liters. And then you continue to do your factor label line conversions until you get it into the format of moles per liters as we've practiced. Look at this sample problem. Solve it along with me in your notes. Suppose we take 25 ml of a 1.5 molar solution and dilute it to a new volume of 1 liter. What will be the new concentration? So does this question give me molarity, ask me to find the molarity, or ask me to dilute? Well, they do give us a molarity, and they do ask us to find one, but the word dilute is the clue. Because they're asking us to dilute, we're going to use the dilutions formula. MCVC equals MDVD. Now I have three numbers, 25 mils, 1.5 molar, and 1 liter. Again, the word of is a linking word. It means these go together. These are either both the concentrated or both the diluted. Let's take a look at what it says. Suppose we take 25 mils of 1.5 molar and dilute it. Well, if I'm going to dilute it, these must have been my concentrated values. Milliliters is a measure of volume, and molar is obviously a measure of molar. So those will end up on this side of the equation, and the 1 liter will end up being the volume of the diluted. Now, in this case, I've gone and changed the 1 liter by timesing it by 1,000 to 1,000 mils. And the reason I've done that is because the unit on the other side was in mils. Now, I could have changed this one to liters as well, but this was just the way I chose to do things. When we rearrange to solve for the answer now, you can see that mils on the top can cancel mils on the bottom, and we'll get an answer in molarity, which is what I want. It turns out that we will have 0.0375 molar solution as our new concentration. It's being diluted. It's a much smaller number than the original, which is what we'd expect to have happen. Let's look at another problem. Suppose we want to make 1.5 liters of 0.25 molar HNO3 by diluting concentrated 16 molar. How much of the concentrated acid would I require? Again, in this question, if we take a look at the words, I see the word dilute. So I know this is a dilutions question, and I'm going to write the formula MCVC equals MDVD. I now need to decide where these numbers go. I want to make 1.5 liter of 0.025 molar. Again, the word of is a linking word. It means both of these go together. The other number that I was given is 16 molar. I have two different molarities. The bigger of the two is always the concentrated one. So 16 molar is the molarity of my concentrate. 0.25 molar, being a much smaller number, would be the molarity of my diluted. Because the word of links these together, the 1.5 liters is the volume of the diluted. So when I substitute the numbers in the equation in place of their variables, I can see that I'll be solving for the volume of the concentrate, which is what I'm asked to do. Rearranging to solve for VC, we can see that molarity on the top cancels molarity on the bottom, and our answer will come out in liters. 0.25 times 1.5 divided by 16 is 0.023 liters. Or if it's easier for you, you can times it by 1,000 and change that into milliliters. And that's entirely up to you. It's an equivalent value, so you pick the amount that makes sense. So I'm hoping that you can now determine if a problem is a dilutions question. Again, look for two molarities in the same question or the word dilute as a clue. If you have a dilutions question, use the formula MCVC equals MdVd. This formula is given to you on your periodic table cheat sheet, so I'm not asking you to memorize it, just knowing when to use it. Given that, you should be able to solve for volume or for concentration using these dilutions questions, figure out how to make the solution, and explain how to make it using a sentence. There is lots of practice available for you. In your textbook on page 486, there's a few questions specifically about dilutions. And then in your workbook on pages 33 to 41, there are several problems for you to solve that include both dilutions questions and regular calculations of molarity and volume. So this is a lot of practice that is available for you guys to get good at the skill. Do as many as you feel like you need to feel that you understand how to do these problems. And this is the end of the solutions unit. After the review, we'll be working on our unit test for this topic, and then we'll be going on to our final unit on organic chemistry.